Innovation is so important because when we are focusing on smart charging, we have different problems and different areas of solutions, and we will end up with suboptimal solutions if we do not take benefit what a digital innovation can bring us.
Yeah, we try to be innovative, so we try to be to prove that new technologies can work. So we did that with the transparent charging station. We also did that with the IOTA charging station. And now we're at the point that we show that decentralized solutions, like with, for example, LoRa, can work to directly control a charging station.
We have been exploring the field of smart charging for a few years right now. And when we look at the solutions we are investigating, the solution of direct control from a DSO to a charging station, we did not gain experience in that area yet. So, and these solutions, they are part of that area, and we decided to dive into this subject right now, and we ended up with these innovations.
The reason we look at these proof of concepts is to have a backup solution. Smart charging is great if it works, but we need to keep the grid running. So what if there is no telecom connection? What if the cloud, so all the cloud servers are down? We need a way to directly control then the charging station to make sure that there's no overload on the grid. And both solutions could be a way to do that.
The urgency is quite high in the sense that we see quite a good rise of the adoption of the EV, and at the same time we see that the quite large concentration of EVs in a certain area, which means that EVs are going to be charged in a certain area, and probably more or less at the same time. And EV as such, an average EV asks for 11 kilowatts from the grid, which is comparable with 10 households. So when all the EVs in a certain area, and the last estimation is that we are getting 25 areas with more than 150 EVs, you can imagine that the peak demand of these EVs is quite high. And the question is if the grid is built for that kind of capacity demand.
This proof of concept is a way to show how you can control load of a charging station directly. So no need for any control via the back end of the charging station, but direct control to the charging station if that is needed. So if the grid is reaching its maximum capacity, this proof of concept shows that you can have a decentral way of controlling the charging station and a central way. The reason we show these concepts is to have a hybrid solution. So one solution using the smart meter, which is already in the homes, and the other solution is a really decentralized solution, where you don't need a telecom provider, where you don't need the cloud servers. Everything is locally, so all the logical is locally, and also the connection, the wireless connection is set up locally.
When it looks like there's going to happen a power failure, a lot of power consumption, the transformer measure results are going to a centralized system which will analyze the measurements and the power consumption, and if it's too high, a signal will be sent to the charging station to reduce the power by smart charging. What happens is there will be calculated which value is accessible without causing a blackout, so you will be charging a little bit slower for a short amount of time. It's new to use a smart meter in this kind of way, because it's normally indeed for measurements or other grid operation features, but now we use it to control or communicate with a third-party device, and that's new in this. We tested it with help from a grid operator. They have all the tools to communicate with all kinds of smart meter devices. So we had a theory, investigated, and then we started testing it in real life with a test setup with all kinds of smart meters, and we saw that it worked. We could send all the profiles for charging stations we wanted without any problem. And if communication is getting lost, then the message is still available. This one is for in the early stage to adopt the smart charging, the social module, because it's with a small amount of adoptions, it's possible to convert a traditional charging station to a social one. The grid operator is already able to communicate with the smart meter. The smart meter is already inside the charging station, so that should make things a lot easier. I'm very proud because it's a new way to communicate with smart meters and give them extra functionality, and also hopefully a very low step to introduce smart charging and prevent blackouts with existing hardware.
Yeah, we are looking for a system that is capable of controlling the charging station directly in a local fashion, so there is no central system involved in controlling the charging station. When a lot of cars start charging, the transformer will see that there is a congestion coming up, and in that kind of event the transformer can decide to send a signal to the charging stations so they can lower their charging speed. The transformer will recalculate after a few seconds if there is more reduced speed needed, and if that's the case it will send a new lower signal to the charging station to reduce its speed more. The system is designed to be doing a kind of emergency system, so if the rest of the smart charging systems doesn't work or don't cooperate between each other, then this system will kick in and prevent the blackout, but hopefully it will be a few times in the year. LoRa is a technology that is used to communicate between two systems. It's called long range, so it's a kind of modulation on the frequency domain to control the data sending over. You can see it like a technology like your normal RF remote system, but then a little bit more complicated, so it's more resilient to send the data between two systems. We use LoRa because we did a project before, and that project also uses the LoRa technology, so we had some familiarities about this kind of technology, and it was easy to use. The Internet of Things is connected devices in this kind of way that the transformer is connected to the charging station. But it's not sending information from the charging station back to the transformer. The only way that the transformer can know that there's something happening is to measure multiple times and see if what he's asking will result in a change in the amount of power that is drawn by the charging stations and the rest of the households. The reason to use a one-way communication is also to make it more resilient, because you're going to use it hopefully 1 or 2 times in the year, and then you want to be sure that it really works. So that's the reason it's one-way communication, it's not two-way communication. There's a chance that it will be failing more often. We tested it on the Elaad premise. There is a charging station on site, and it's capable of doing the communication between the transformer and the charging station. And it's there now for more than 3 months, and there are a lot of cars that are charging there, so it's worked very nicely. And the advantage is there are no third parties involved, so you can directly communicate between the transformer and the charging station, so there is a direct control of the signals that you're sending out. It's a decentralized system, so if it fails, it will only fail in a local area and not in the Netherlands. So in this way, it's more resilient to problems. I'm very proud on the solution, and I hope it will be introduced in all charging stations in the Netherlands.
When you do experiments and explorations like this, normally you look quite far ahead. Because also these technologies are young and you do not know exactly what the potential for scaling up is. When you look at these two developments, I have the impression that the implementation period, also based on the maturity of these technologies, is not that far away. So I'm looking for methods, pilots, to investigate the scaling up of these technologies.
Yeah, I think it would be great as a next step to really put this in the field. So have a few charging stations in a single neighborhood where there is a challenge in capacity, that we can show that these solutions also work in the grid when you actually need them. So this is still here in our premises Here we show that it works, but I think it's good to show that it actually works in the field. Yeah, I think it would be great if there are people in a certain neighborhood that have a lot of charging stations, watch this and see, hey, we want this solution, to test it or to prove that it works. Yeah, make sure to call us or drop me a mail. That would be great.